Okay, so let me introduce you Hans-Juergen, who has the last session during today, and he will tell you something about combining graphs and trees and schemas and whatever.
Thank you. XML technology is very powerful, but also very limited. And the more you are aware of the power, the keener your interest in reducing the limitations. A key problem is rooted in the very paradigm of XML, which is tree-structured information. And this leads head-on to the challenge of combining XML tree technology and RDF graph technology. First, a glance at what to expect. I shall start with an elaborate argument why the integration of graph and tree is so compelling a challenge. We take a look at SHACL, a new schema language for RDF. And then I shall introduce you to SHAX, which is an XML syntax for SHACL. And in the end, I shall argue that SHAX is not only an XML syntax for SHACL, but also a modeling language in its own right, an abstract modeling language which can not only validate RDF, but also XML and JSON. The power of XML technology is based on an ingenious scheme of addressing information, XPath. And it presupposes tree structure. On the one hand, this is not a problem, because trees are ubiquitous. But on the other hand, we should remember that trees are based on the containment relationship. For example, a book element contains all the elements. And there is something arbitrary about this containment very often. It would be equally true, I think, to say that an author contains his books. There's no right or wrong, but it depends on your perspective, on the focus of your interest, on where you stand. It's like in real life, where you can say the tree is behind the house, and the house is behind the tree. So XML structure is tied to a specific perspective, and this means that XML is perhaps not an appropriate choice for large-scale enterprise modeling and enterprise data stores. And this cuts off XML from a full realization of its potential. Enters RDF, which excels in relating information without assuming containment. An RDF model is fit to capture complex reality impartially. And RDF datasets can be viewed as points of truth capable of servicing a very wide range of information needs. But there's a downside to it. Using RDF means dealing with graphs. And a graph is so much more difficult to understand and to process in comparison with trees. And therefore, I think that XML and RDF are complementary technologies. And the more you think about it, the more amazing it is how complementary they are. It is mind-boggling. And I think there is so much to be gained by combining the two intelligently. Integration of XML and RDF, what does it mean? I think first of all, two things. Free transformation between the two data formats and mutual support. One technology using functionality offered by the other. For example, an X-query processor invoking SHACL queries in order to get hold of relevant document URIs. But I think at the heart of integration really lies transformation. It enables us to view RDF datasets as a single point of truth which communicate with the world via tree-structured messages. So how to approach this challenge of transformation? Let's start with exploring the intrinsic relationship between XML and RDF. They are based on common ground, a common abstraction, which I would call an information object. This is just a container of named values which are either atomic, like numbers or strings, or themselves containers of named values. And RDF calls these containers and their content resources and their properties. And XML calls them elements and their child elements and attributes. And I propose to call them just information object and its properties. This perception leads straight on to a generic mapping between XML and RDF, which you might regard as a canonical transformation. In RDF, there are 5 kinds of things you encounter. You have first 3 kinds of nodes: resource nodes, blank nodes, and literals. And then you have 2 kinds of resource IRIs, internationalized resource identifiers, resource IRIs and the property IRIs. Now, how do these things map to XML? An RDF resource node is in XML a complex element. A blank node is a complex element. A literal is either an attribute value or simple element content. Now, what is a resource IRI in XML? Remember that an RDF resource is represented in XML by a complex element. So obviously, the IRI of the resource is the value of some item found in the content of this element. So I think it's either the value of a dedicated attribute with just these explicit semantics could be called RDF IRI, owned by the element representing the resource, or alternatively, it could be a value found at a configurable XPath. And I would be very glad if the W3C could decide on standardizing an XML attribute for conveying an RDF IRI with these semantics. The element owning this attribute represents an RDF resource with a resource IRI equal to the value of the attribute. It would be a microscopic spec, but I think it would open new possibilities. Finally, property IRIs map naturally in XML to element and attribute names. Remember that XML names are qualified names, and there is a well-defined mapping between IRIs and qualified names. It's even found in W3C specs. So, in theory, we are almost done. We translate our generic mapping into generic code, and we have a transformation machine for RDF and XML. However, usually the results of such a mapping will not meet real-world requirements. Think of messages. We want them to look purpose-built and not like the result of some kind of translation. It's like in real language. We want to hear real language and not something which is recognizable, a translation from another language, which is ugly. So we have this generic mapping conceptually, but we must tweak the results to have them really be useful. So we will need filtering to get rid of things we don't want to have in the transformation result. Often renamings will be appropriate, and structural adjustments like additional grouping nodes or the removal of intermediate nodes which add complexity unnecessarily. But to perform this tweaking, we must know exactly where to expect what. And that's another way of saying we need models. We need models on both sides of the wall. On the XML side, we have XSD, which gives us a precise picture of the grammatical structure of the data, exactly what we want to be guided by our transformation. On the RDF side, we have a problem, because the main modeling language of RDF is OWL. And OWL has been designed for inference and not for validation and prediction. OWL is inappropriate for our purpose. Fortunately, last year, a new schema language for RDF has appeared, which is SHACL. Like XSD, SHACL can paint a precise picture of the grammar of RDF data. So now, only now, we have two model languages on the XML and on the RDF side, so that models can be well aligned. And this is the ideal preparation for having high quality transformations. SHACL is a W3C recommendation, and the first sentence of the spec characterizes the language as describing and validating RDF graphs. The first thing to notice is that SHACL is itself an RDF vocabulary. Small wonder, because XSD is also an XML vocabulary. This little example, taken from the introduction of the spec, describes RDF resources belonging to the RDF class person. According to the model, a person has two properties: a social security number and works for, giving us information about the companies a person is working for. The model also gives us cardinality constraints and type details. On the right-hand side, you see RDF data, which belong to the RDF class person. And these resources do have the expected properties. However, they violate the model, in one case due to a regex, in the other case due to a cardinality constraint. So SHACL describes and validates the RDF data in exactly the same way as an XSD would describe and validate XML data. Therefore, on first glance, one might say SHACL is XSD for RDF. But there is more to SHACL. It also supports the construction of highly specific constraints using the SPARQL language. And in this respect, it resembles more schematron. Therefore, one might say SHACL is XSD plus schematron for RDF. Okay, obviously, we have a very powerful schema language now for RDF. And I ask myself, is this a breakthrough for the integration of XML and RDF? I think it is certainly a significant and necessary step, because now, at last, we can describe RDF data with the precision we need for high-quality transformation. However, there are also issues. First of all, it's the use of the RDF model and syntax for SHACL models. Few IT professionals are really familiar with RDF, and there's very limited tool support for RDF resources, at least compared with XML resources. Another problem is that For transformation, grammatical structure is key. But grammatical structure can be described in SHACL, but not always explicitly. In some cases, it has to be, so to speak, emulated. I'm thinking of the choice group, which is a very important grammatical element. You can write SHACL so that the result is a choice group, but it's not understandable and explicit like as a choice group. And this somehow blurs the meaning of the model. And I believe that these problems can be solved by XML. By an XML syntax for SHACL, which I call SHAX. The possible benefits I divide into 3 categories: simplicity, abstraction, unification. Simplicity first. A SHAX model should be simple to write and simple to read and understand. A SHAX model should be easy to transform and to process, and even easy to generate. Now, what does abstraction here mean? When we add this XML syntax, we add another level of abstraction, and this gives us a unique opportunity to add high-level constructs for making the modeler's intent more explicit. Think again of the choice group. This gives us the opportunity to enable the modeler to say, I want a choice between A and B, and it is as simple as that. Finally, unification. If SHAX can be translated into SHACL, it should also be possible to translate SHAX into XSD. And this would mean that suddenly the SHAX model is something like a unified model which can be used for validating both RDF data and XML data. Now let's check in how far SHAX really accomplishes these envisaged benefits. We return to the simple SHACL model we saw before, and here's a SHAX representation. The person shape is represented by an object type element. Its child elements represent the properties of the resource, after which they are named, and their attributes give us the cardinality constraints and type details. So it's pretty straightforward. Now let us evolve a little bit this model in order to get a feeling what it is like to write SHAX. First, we notice that the second property does not yet really give us a type. The class means that the property values belong to the RDF class company. There's no information about the structure of the resource. So we add a second object type describing company resources and reference it via a type attribute on the works for property element. Next, we make things more interesting by adding a little grammar. We introduce a choice group, which is very easy in SHAX. You use a SHAX choice element, and its child elements represent the choice branches. And if one branch has more than one property, you wrap these properties in a SHAX pgroup element. Next thing, we notice that the first property has a simple type, which is locally defined. It's always nicer to have globally defined types. So we introduce a global type definition, which in SHAX is a data type element, and reference it again via a type element. And finally, we add order to our model. If we want the values of works for to be ordered, this can be accomplished in RDF using an RDF list. And in our SHAX model, all we have to do is add an ordered attribute. So we have arrived at a small model which showcases the basic capabilities of SHAX. And it is very readable, I think, and it is easy to imagine now going on and building a large type system along these lines. Now let's take a look at the SHACL generated from it. So it's, I know it's very small print, but I think the impression is already sufficient to believe it's not so easy to read, it will not be so easy to write, and probably not so easy to process. So, after this example, a summary of the SHAX language. We have 4 kinds of building blocks: object types, data types, properties, and imports. Object types and data types you saw. You saw also properties, but they were locally defined. And property as a building block here means a globally defined property, which can be referenced from within an object type. And this is equivalent to what in XSD is a top-level element declaration. And finally, an import is just what the name suggests. It pulls in another model into the current model. And in the context of imports, it's interesting to note that in SHAX, you don't have target namespaces. You can mix namespaces in a SHAX model document as you like, and therefore it is very simple to compose a model from a type library by just listing imports. Concerning advanced features, I would like to mention union types, type extension, and substitution groups, all things we are familiar with from XSD. So I hope so far that I could convince you that SHAX did give us, and does offer us, both simplicity and abstraction. Concerning abstraction, remember the choice group. Now, how about the unification? Well, a SHAX model can be translated into a SHACL model which constrains RDF data. That's obvious. But a SHAX model can also be translated into an XSD which constrains XML data which are equivalent to the RDF data constrained by the SHACL model. And similarly, SHAX can be translated into a JSON schema constraining JSON, which is equivalent to the RDF constrained by SHACL or the XML constrained by the XSD. Thus, SHAX emerges as a modeling language in its own right, an abstract modeling language, which describes data structures and data types, but does not impose a particular data representation language. I want to give you an impression of SHAX and its translations. So here, once more, our SHAX model, which can be translated into XSD, can be translated into JSON schema, and can be translated into SHACL. SHAX models are easy to write, but even easier it is to generate them. And they can be generated from XSD. And this means that tons of modeling work are ready for transportation into the RDF sphere where they may become SHACL models. The transformations are accomplished by software which I call a SHAX processor. A SHAX processor supports at least 4 operations: translation of SHAX into SHACL, SHAX into XSD, SHAX into JSON schema, and XSD into SHAX. A prototype is available on GitHub. 2 disclaimers. First, the translation into JSON schema is still work in progress and will be released by the end of the month. And the translation of XSD into SHAX has still some limitations. But these are there are no problems behind this, but just time that I did not had enough time to complete it until the present day. So I wonder if SHAX might be used as a pivot or turning point where you bring your model work in order to let it travel into various countries. And I think the concept has been proven, but I'm also aware that very much work is ahead in order to achieve the comprehensiveness and robustness which is required. And any kind of feedback, bug reports, feature requests would be highly welcome. Concerning the conceptual work, I have a strong feeling that the idea is still in need of other minds, perhaps better minds. And perhaps someone will join me who shares my interest in elaborating an abstract modeling language, or in other words, connecting the seemingly unconnected. Thanks.
Well, thank you very much. I think this presentation will probably raise many questions. First, thank you, Stephen. John.
Stephen Pemberton, CWI. That attribute you were asking for, I couldn't be sure from your slides, but I would have said that the RDFA about attribute, which is in a W3C standard, would satisfy your need.
Yes, but it's meant to be used within RDF XML. But that's an idea. You could just uncouple it from it. You're absolutely right. It didn't occur to me. Yes, thank you. That's great.
So there is another question from John Snelson.
Mixed content, by which I mean to say it's entirely possible to translate a lot of XML documents into RDF, but it comes down to whether you're treating XML as ordered or whether you're treating it as unordered, and particularly the case of ordered XML, which is important, I think, is mixed content, and it's a lot harder to translate in any meaningful way in that case. So, question: what would you do with SHAX to kind of to still be able to take advantage of mixed content parts of XML documents?
A straight answer: I did not think about that at all, because personally, I have no relationship to mixed content. It is something I have not yet thought about it. Yeah.
So we still have time for one question, probably the final one. No one? What you are looking for? So thank you very much, Hans-Juergen.